right, so let's go through this. When we have our set of points here, this is a relation. So relation's just a set of points. Whether or not it's a function will depend on whether it has one input for each output, one y for each x. So if we're just listing what the domain and range is, for the points, each of these is x, y, x, y, x, y. So the domain is just the list of x's, the first number in each ordered pair. So just say 14 and 4 and 17 are the domain. The range is just the y's. So you say 19, 14, and I think that's -1. It looks like it has a little negative sign there that didn't copy very well. And then if it asks, is it a function? What we're looking for is, does each input have a separate output? And there's a diagram we can draw to figure this out. So I'm going to draw this kind of small. I'm going to do the domain in this little bubble, 14, 4, and 17. And then the range would be 19, 14, -1. So this is the x that's going into some equation that we don't know. And it's coming out with the output 19. That's why 14 and 19 go together, input, output. The 4 is going into an equation, we're getting out 14. 17 is going in, we're getting out -1. This is a function, we can say yes, because each input has a unique output. I'm not putting 14 in and getting 2 different answers. So we would say that that's a function. I always think of it as being a computer that's functioning. If I tell it to print, it prints. If I tell it to save, it saves. It doesn't like change its mind and do 15 different things when you use an input. All right, so when we go to look at the next one, we can go ahead and do the domain and range first. For the domain, remember these are all x, y, x, y, x, y, x, y. The domain is going to be -3 and 4. And they list -3 again. You do not write it a second time. Save yourself a little pencil. You only write each number once. So if it shows up again, don't write it again. And then the range is 7, -5, 2, -8. So if we think about our inputs and outputs from our domain to our range, this is called a mapping that I'm drawing here. Actually, I'm going to have to make this one a little bit bigger. All right, so I'm going to have -3 and 4 and 7 in the domain. And then my range has to be a little bigger because it has 7, -5, 2, -8. The -3, when I put it into my equation, is giving me 7. It's also giving me 2. The 4 gives me -5, the 7 gives me... So when I put this input in, I'm getting 2 different answers. That makes this not a function. There are equations that work that way. Equations of a circle is one example that's not a function, where you can have one x value that has 2 different y values, but it's not a function.
So if there's like 2 of the same ones?
Yes. So one way that you can tell that this is not a function, let me highlight this. If you have repeating numbers in the axis, in the domain, then you know it's not a function. If they're repeating and have different outputs, then you know it's not a function. So what we can write over here is no, we have x's that repeat.
Does that rule only apply to x's? Or
only to x's. Only to x's. So that's a good question. It only works if you have x's that repeat, because it's okay if you have 2 different inputs of the same output. What we want is for each input to have a unique output. Shh. Okay, so when you're trying to tell if something's a function from a graph, I'm going to start with, this is called a discrete graph, which means that the points are not connected. Okay, so we're going to go through and write out what each of these points are. This one at the top is 2, 4. This one's 2, 3. This one is 2, -5. And this one is 1, -5. So once I know what those coordinates are, we can do what we were doing above. It's just a list of points now. So my domain is going to have 1 and 2 in it. Oh, and sometimes when they write these sets of numbers, they'll put funny little brackets on there. I won't make you do that, but realize that sometimes you might see that. So there's only 2 numbers in the domain. But there are 4 numbers in the range. Or no, I'm sorry, there's 3 numbers in the range. I've got -5 and 3 and 4. So it's asking, is it a function? We have x values that repeat, so that's going to be no. If I drew the mapping of this, I'm just going to have 1 and 2 in the domain. And then over here in the range, I'm going to have -5 and 4 and 3. And you're going to see that 1 goes to -5. 2 also goes to -5, and that's actually okay. But then 2 goes to 4 and to 3. It's this 2 right here that makes this not a function. Because when I put 2 into the equation, I'm getting 3 different answers. If I put something into an equation, I want to have the same answer every time. Okay? Then if we look down at the next one, we can go through our points. So this is -4, 4. This down here is -2, 0. This is 0, 2. This one's 2, -1. 3, -5. And 4, 3. So lots of points. And you wouldn't necessarily have to label them on the picture. I just do that when I'm teaching so that people can see where I'm getting the domain and range. So the domain, I like to just go left to right. It's -4, -2, 0, 2, 3, and 4. And then on the range, I like to go bottom to top just to make sure I don't miss anything. So I've got -5 as a y value, -1 as a y value, 0, 2, 3, and 4. So just, I like to go from the bottom to the top or left to right just to make sure I don't leave anything out. Is this one a function? Is this one a function?
Yes.
Yes, because I don't have any x values that are repeating. All right, now, this one I always thought was interesting if they ask you for the domain and range and they give you a table, because literally you're just reading it off the table. So the domain for this one is going to be 3, 5, 8, 7, -2. The range is going to be 2. I only put it down one time. 3, 5, and 8. Is this one a function?
Oh, yes. No, yes.
Oh, no, yes.
Yes.
Senor.
Okay.
Look at what I wrote.
And then look at the next one. The domain is going to be 12,
No, it's not.
-13, 4, and 9. And he's already saying no. Why is it no? Because we have 12 as an input, giving us 2 different outputs. So the range is -3, 5, 4, -1, 0.
Okay, did they ever give you the same